Welcome Algebra 2. I'm going to take the time to go over the Quarter 2 review packet with you, problem by problem. So first off, if we look at number 1, this is a Unit 1 question, and it's asking you what is the equation of the graph below. So your two options are between a log graph or a radical. This parent function takes on a radical, so then that means we can eliminate A and D from answer choices. Radical functions start at 0, 0. So we're going to move over 1, 2, 3. So left is really a negative direction. And remember, the movement left goes with the x and is the opposite. So it would be plus 3. And then we would go down 1, minus 1. So your answer here would be C. Moving on to number 2, it is a absolute value problem. It actually falls into your parent functions as well. It says which graph best represents the solutions for y is less than or equal to the absolute value of x plus 2 minus 3. So if we look at this, the movement should be left 2 and down 3, and it will be shaded below the line. So our graph that takes on those characteristics is graph A. Number 3 says, what is the solution to the quantity x plus 4 is less than 2? So remember, with absolute value, you have to set up two equation inequalities in this time. So our first one will stay exactly the same. It'll be x plus 4 is less than 2. But our second inequality, we switch the sign of the inequality, and we switch to negative 2. So our second one will be x plus 4 is greater than negative 2. And now we need to solve. We want to get x by itself, so minus 4, minus 4. So we should get x is less than negative 2. And our second one would be minus 4, and x is greater than negative 6. So I like here to kind of jot this on my number line to kind of help me figure out which, if it's an and or an or statement. So if x is less than negative 2, negative is roughly around there, less than would then be pointing to the left. X is greater than negative 6. Again, that would be everything in between, so that makes it an and statement. And with that being said, your answer is B. Number 4 is also an inequality that an absolute value that you have to solve. It's an equation though. So remember, you want to isolate the absolute value before you start. So in order to do that, we have to subtract 1 from both first. We get negative 2, absolute value plus 2. And to get rid of the negative 2 out in front, remember, we're going to divide each side by negative 2. And we get absolute value plus 2 equals negative 4. And this is where you might want to say, time out. Is this true? So we want to ask ourselves, can you get an absolute value? Remember, absolute value is always going to be a positive number. Can a positive number ever equal a negative number? It can't. So your answer would be no solution. Number 5, we need to remember how to multiply radicals. So in order to multiply radicals, I multiply the outside numbers together and the insides, and then I simplify. So my outside numbers are negative 6 times negative 1 to make positive 6. Inside my square root, I have 3x cubed. And that is going to make 144 x to the 4th. And I'm going to quick check my answer to see if any of those are an option. Letter E is the first one. But I need to keep going because it wants all the possible answers. So now that I'm here, I'm going to break down 144. 144 is a perfect square. It's 12 and 12. So you can kind of see, so you can pull out the 12. And the x's would break down x is x squared. So you end up getting 6 times 12 x squared, and that's it. So that gives you the answer of 72 x squared. So C, but also another one that actually works as well is A. So A is just without breaking down the variables and is also a solution. Number 6, none of these answer choices work, so we're just going to solve out the problem by hand. And for number 6, you have a radical in the denominator. You are not allowed to have a radical in the denominator, so we have to get rid of that. We get rid of the radical in the denominator by multiplying top and bottom by the denominator. So you're going to multiply by 3x, square root 3x. When we do so on the numerator, we should get now you need to simplify each one. If I simplify 15 squared of 15x squared, 15 breaks down to 3 and 5. X squared is x and x. Take out my twins, so I would get x square root 15. On the bottom, square root 9x squared breaks down to 3 and 3, x and x. I have twins, so we get 3x. So you get x square root 15 on numerator. So divide x. And then from here, we can see that our x's actually cancel with one another. And watching the x's cancel makes your final answer the square root of 15 divided by 3. Number 7, in order to solve a radical question here, we need to isolate the radical. So we first have to move this negative n by adding n to the other side. So we get n plus 4 equals the square root of minus 2n. Now, if you remember correctly, to undo a square root, you must square both sides. So when we square the square root, it cancels out the square root. And now we have to square n plus 4. So if you know FOIL or box, really what you're doing is n plus 4 times n plus 4 equals 7. Before we move 7 and negative 2n over to the left side, we have to multiply the quantity n plus 4 times n plus 4. So again, we are going to use the box here to help me with multiplication. N plus 4, n plus 4. So we get n squared plus 4n plus 4n plus 16. Combine like terms, that gives us 8n. So n squared plus 8n plus 16 equals 7. When we get here, we have to make the left or right side 0. It's easiest to move everything on the right to the left. So we're going to do that by the opposites operation. And I just kind of lined it up under each term. So we get n squared n plus 9 equals 0. Now we have a quadratic. In order to find our solutions, we have to take, you can either factor, or it's actually easier if we take our calculator here, and we go to y equals, and you clear this out and type in x squared plus x. And I'm just going to press zoom 6 to make sure my calculator goes to standard screen. And we want to see where our x-intercepts here are. Our x-intercepts crosses at -1 and -9. So that is going to be our answer, which is B. Number 8 is asking you for the sum of this infinite series. So whenever you see the word series, you definitely want to pull out your formula sheet. And when you see the word infinite, you want to find the formula with the infinity sign. So that means we are using the formula S sub infinity equals A sub 1 divided by 1 minus r. Which means I need to know what a sub 1 is, and I need to know what r is. Well, a sub 1 is the easy one. That's 150. So a sub 1 equals 150. And remember, to find r, you take the second term and divide it by the first. So 50 divided by 150 is going to give you 1/3. So now that we know a sub 1 and we know r, we're going to plug into this formula. S sub infinity equals divided by 1 minus 1. You can just plug that straight into your calculator, and your final answer is 245. Number 9 says, which statement illustrates the transitive property? Remember, the transitive property is if A equals B and B equals C, then we can assume that A equals C. So the only one that's taking on this full property of transitive is letter C. Which of the following is an illustration of the addition property of 0? So anytime you're adding 0 would be the addition property of 0, so that would be D. Number 11, we need to simplify this -4 here. So remember, when we have the square root of a negative, the negative comes out as, right? It's really -6i 4. And the square root of 4 is 2, so it's -6 times 2. So your answer is A. Number 12, this one you have to go in and you need to simplify each one. Okay, so you need to do this problem 4 times, starting with I to the 47th. So remember, we divide that by 2. So that is going to give me I squared raised to the 23rd power with remainder. And remember, every time you have a remainder, you have that leftover I. So I squared is -1. That's what we had to memorize. So we plug in our calculator, parenthesis -1, parenthesis raised to the 23rd. And that's going to give me -1i. So that is a solution. I'm trying to find negative. So I to the 47th is 1. Next, I'm going to do I to the 51st. I'm going to divide that by 2. That ends up giving me I squared raised to the 25th with a remainder of I, which is -1 raised to the 25th with a remainder of I, which gives me -I. So with that being said, this is also a solution that you're looking for. So now we're going to do I 21st. We're going to divide that by 2. We get I squared raised to the 10th I. So that's -1 raised to the 10th. -1 raised to the 10th, so that is not a solution. And last but not least is I to the -51st power. So first things first, negative ones move down to the denominator. So on the numerator 1, and then now it's positive on the bottom. We actually already did I to the 51st power, and we ended up getting -I. So know that this is, we cannot have an I in the denominator, just like we can't have radicals in our denominator. So you're going to multiply top and bottom by I. So remember, this is a -1i. So keep that -1. Maybe you need to write it in. So on the top, we get times I, give me 1 times I squared is -1. So really you have -1 times -1. So I divided by -1 times -1, which is +1. So you have I over 1, which is I. But again, we are looking for -I, so that is not a solution. Number 13, Remember, when you have subtraction, you need to distribute the negative sign to the parentheses. So we have 1 plus 6, 1i. Really what it does is it changes all your signs. So we just want to group together like terms. 1 plus 6 and plus 1 go together. Oh, I'm sorry. This is a negative 1. I made a mistake. I didn't change the sign. Negative 1. And when we add 1 plus 6 minus 1, we end up getting 6. And then we have the I, positive 1, plus 6i. So positive 1i plus 6i is at 11. So your answer is going to be D. Number 14, you have to make your box because you're multiplying these two binomials together. So you have negative 5 plus I. And then on the side here we have minus 4i. So we're going to multiply in. When we multiply in, we get negative 30 plus 6i plus 20i and minus 4i squared. Now we have to take our terms inside of our box here and combine them. Negative 30 plus 6i plus 20i minus 4i squared. And we're going to combine like terms again. 6i and 20i go together to make 26i. But remember, I squared is the same thing as negative 1, so this is really negative 4 to make that positive 4 and negative 30 out front. So now if we look at this, negative 30 plus 26i plus 4, if I combine like terms, ends up giving me negative 26 plus 26i. So that answer is A. Number 15 says to describe the amount and type of solutions from the expression below. So this is from Unit 6, and this is talking about your discriminant. So remember that for your discriminant, if you get a positive number, you have 2 real. If you get 2 positive, no. If you get 0, you have 1 real. And if you get negative number, you have 2 complex or imaginary. Okay, so just kind of keep that in mind. That's a refresher. So in order for you to do this, it has to be in the standard form ax squared plus bx plus c. So you have to start off for probably 1. So we have squared, 6 good. With our A, 6 is our B, and 1 is our C. And now that we're here, we have to do the discriminant, which is B squared minus 4AC. So you have 6 squared minus 4 times 6 squared is going to give you 36 minus 8. So this is 20. It's a number. So your discriminant is 28. So that's going to mean you have 2 real solutions. Number 16, you actually have to solve using your quadratic formula here. So remember, if something is missing, you put in a 0. So we have 9x squared plus 0x minus 45 equals A is our 9. Sorry, 9 is A, B is 0, and negative 45 is our C. So again, we're going to start off by doing our discriminant, B squared minus 4AC. So we have 0 squared minus, and when we do so, we end up getting 1,620. From here, we have to take the square root of that number. Unfortunately, 1,620 is not a perfect square, which means I'm going to have to break that down. So you're going to break it down into 10 and 162. 10 would be 2 and 5. 162, 2 and 81. 81, 99. 3 and 3. 3 and 3. Came in here and wrote down all of our prime numbers. It ends up being 1, 4 twos, 2 threes, and a 5. You want to take out twins. So you end up taking out 2 times 3 square root 5. So you end up getting 2 times 2 is 4. I'm sorry, I misread my own numbers. There's only 2 twos, not 4 twos. So, going back here, it's 2, 2, a 3, a 3, a 3, and a 5. So again, taking out our twins, it's a 2, a 3, a square root 5. 2 times 6, 6 times 3 is 18. So we get 18 square root 5 when we break down our discriminant. And now we're going to take that all the way back and plug this into our quadratic formula. Remember quadratic formula? X equals negative b, so 0 plus 18 square root all divided by 2 times 9. So when I write this down, it's x minus root 5. And 18 over 18 reduces to the root. So your answer would be number 17. We have negative 2i minus 6 divided by 3i. We're not allowed to have i's on our denominator, so you need to multiply top and bottom by i. When you do so, remember you're really distributing the I to the numerator. So you get negative 2I squared minus divided by 3I squared. Remember, I squareds are negative 1, so this is negative 2 minus 6I. And if we simplify that, we get 2 minus 6I. Divide by negative 3. So your answer is C. To simplify this and keep it all under negative 3, we're going to make the numerator negative 2, and then a double negative here. That's a positive 6i, and then it's still all over 3. So it's the same thing. Number 18, we have to predict the solutions to the graph below for the function. This is supposed to be y equal 3x minus 15. So what you actually have to do is you have to graph this particular line and predict how many times it's going to cross the quadratic there. So if you don't remember how to graph a line, that's fine. We can use our graphing calculator. So you're going to go to equal and you're going to plug in negative 3x minus 15. And you're going to hit graph. And you can see what this line looks like, so you can see the general shape of it. But let's actually pick points. So to do that, you press second graph to look at your table. So one point I can graph is negative 5, 0. What else do we have? Negative 4, negative 3. Negative 2, negative 9. So we'll start with negative 5. 0 would be right here. Negative 4, negative 3. 1, 2, 3. And negative 2, negative 9 would be down here. And you can see if we made our general shape of our line, it would cross how many times? 1, 2. crosses twice, so you would say C. Number 19, in order to solve this, we need to solve each equation for y first. So x plus y plus 10 equals 0. So you're going to subtract x and subtract 10 from both sides. When doing so, we get y equals negative x minus 10 for y1. And our second equation, x squared plus y minus 2 equals 0. I'm going to subtract x squared and add 2, x squared and add 2 to both sides. We end up getting y 2. So those two equations. So we're plugging the first one into y1 and your second one into y2. So y equals, it was negative x minus 10. And for y2, it'll be negative x squared plus 2. And hit graph. And we're looking for where these two graphs intersect. You can see this one comes off the page. You can sign, but then disappear with your radix. There's a second intersection happening there. So it's always good to maybe zoom out or zoom fit your function, zoom 0. And when we hit that, we can see our line and we can see our quadratic, and it actually hits twice. So we can see both intersections now. Now, in order to get your intersection, you press second trace, number 5. And we want to come over to the left side and you see the intersection. So it says the word intersection is -3, -7. So that's going to be your first answer. And now we're going to do this again. Second trace. For 5. And I'm going to go offside. The other intersection is happening. And press enter 3 times. And it's 4, -14. So for this answer, you would actually pick 2, -3, -7, and 4, -14. Number 20, all you have to do is identify the solution. So that's where they cross each other. This crosses at -4, 3. And it crosses at -1, 0. And those are your answers. Again, you're looking for where the two graphs cross each other, not where they cross the x-axis. Number 21, it says which number is a 0 to this quadratic you have here. So in order to do this, all you really have to do is plug this into your calculator. Remember, the word 0 means an x-intercept. So here we are trying to find where it crosses the x-axis. So we're going to plug this into y1. So y equals, clear that out, 3x squared plus 14x plus 8, and down arrow, and remember we're here. And now if we hit zoom 6, just remember we hit zoom fit last time, we want to see where this graph crosses the x-axis. So again, you can kind of eyeball one of them. One of them is -4, but the second one is a little bit harder to find. So we're going to press second trace, number 5, and we're going to come over 10 to get to that x-axis, and press enter 3 times. We get -0.666 repeating. X equals 666 repeating. So when you plug this into your calculator to convert this, if you don't know what it is, you would hit second mode to get out, and you would plug in -0.666, and you have to put in a lot of sixes in order for it to convert correctly. And then you're going to hit math, enter, enter, and when you do so, you should get -2/3. So x thirds. So your answer is actually C. So you had to be able to convert that in order to find your answer. Number 22 is asking you for the zeros of the cubic function, and it wants the factors. So remember, x equals 6, x equals negative, and x equals negative 5. So we have to convert these all to factors. So you're making the right side equal to 0. So you're going to subtract 6. X minus 6 is your factor, A. For this one, you have to multiply both by 5. So you get 5x equals negative 1. And then you add 1 to both sides. 5 is your factor. So that would be B. And last but not least, third factor, D. You are doing the exact same thing for number 23. You are creating your factors here. So we have x equals negative 2 over 5, x equals negative 8, and x equals negative 1 over 7. So you multiply both sides by the denominator. 5x equals negative 2. And then add sides. So your first x plus 2. F. Your second factor, multiply 3 by both sides to get 3x equals negative 2. Add 2 to both sides to make the right side 0, and we get plus 2. 3x plus 2 is D. And last but not least, multiply 7 by both sides, and you get 7x equals negative 1. Add 1. And that answer is A. So your answers are A, D, and F. Number 24 is select the polynomial functions with the zeros negative 1, 3 over 4, and 0. So this is x equals negative 1, and x equals 0. As a factor, this would be x plus 1 times, and the factor of x equals 0 is just x. So now what we have to do is we have to multiply our binomial together and then distribute in our GCF of x. So I'm going to multiply x plus 1 times x plus 3x. And if I combine like terms, we end up getting 4x squared plus 7x. We still have to multiply this by x. So when we multiply this by x, really you're just distributing x to each term. So x squared. So that answer would be B. Number 25, we have to select the polynomial function that matches this graph. So the easiest way to do this is plug each one into your calculator and figure out which one is identical to that. So you need to find which ones have x-intercepts of negative 2, negative 1, 2. Now, the real way to do it is to convert these to factors and multiply them all together. So if I converted this to a factor, it would be x plus 2 times x minus 2. So we would first multiply 2 together. Again, we make a box, x plus 2, x. So that's going to give me x squared plus 2x plus 1x plus 2. Combine like terms, I end up getting x squared plus 3x plus 2. And then we have to still multiply that by the x minus 2. Now to save some time, I'm going to keep that and make my box right away. So, and now on the side is this x minus 2. So now, again, we're going to multiply in here. So we get x cubed plus 3x squared plus 2x minus x 2x squared minus 6x minus 4. And again, we still want to combine like terms. Our x squareds go together, and our x's go together. So your final answer is x cubed plus squared minus 4. And that answer was B. Again, you can always just graph it and see if it matches the graph. Number 26 says which represents the number of real and complex roots of the function x to the fourth plus x squared minus 18. So you are going to graph this function and determine how many times it crosses the x-axis. This one, when you graph it, it crosses twice, and you have two complex. Two real and two complex. Which makes sense because it has to add to the degree, and the degree is 4. So 2 plus 2 is 4. Number 27 says identify which zeros below have a multiplicity greater than 1. So remember, if you have your graph, and if it comes up and touches the x-axis and bounces back, that's going to be a multiplicity of 2. If you have your graph and through the x-axis, so right here, that's a multiplicity. So if we look at this graph, hit a -3, nothing's happening. But here at -1, it makes a multiplicity of 3. So we would say at -1. And it comes back down. It hits 2, but bounces back up. And because it bounces back up, that's going to have a multiplicity there as well. It would be a multiplicity of 2. Okay. So where is that happening? X equals -1 and x equals 2. Which is the factored form of 64r cubed plus 8. So you want to start off by identifying what kind of factoring you would need to do here. The factoring we need to do is your sum and difference of perfect cubes. So I'm going to start off by creating my signs with SOAP. Same, opposite, all positive. So my same side would be plus, opposite, minus, plus. Remember, your first binomial is the cube root of each of the. So the cube root of 64r cubed is going to give you 4r, plus the cube root of 8 is 2. And then this would be 4r, 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 and 2. So to middle our quadrant here, our first two go together, fill in your squared. Our middle two go together, times to give you, and our last go together, 2 times 2, that 4. So your answer is going to be letter B. '29, you need to factor this one. This is a perfect square trinomial. So first things first, you want to look for a GCF. We do not have a GCF, so we are going straight into our ACB table. Remember, this is A, B, C. So you have the factors of 2 times -7 is -15. 2 times -27 is -54. So you're finding the factors of -54 here. Those two numbers are going to be -18 times 3. -18 times 3 gives you -54, but if you add it, it gives you -15. So remember, these two middles break up that B value to make your 4 terms. So the A is the same, but the B is here. So it'll be -18x squared plus 3x squared minus 20. Again, this c stays the same. Now that we're here and we have 4 terms, we can put them inside of our box. 2x to the 4th minus 18x squared plus minus 27. Now you need to ask yourself, see going up. Do 2x to the 4th and 3x squared share? They only share an x squared. X squared times what is positive 2x to the 4th. That would be 2x squared. 2x squared times what is negative 18x squared. That would be, and x squared times what is 3x squared. That would be positive 3. So our factors are x squared minus 9 and 2x squared 3. But we are not done. We have to ask ourselves, do we have difference of perfect squares? If I look at my first binomial here, that's a square, that's a perfect square, and it's difference, it's subtraction. So yes, we do. This breaks down to x and x, 3 and 3. So when we set up our binomials, it'll be x plus 3 times x minus 3. 2x squared plus 3. That is not difference of perfect squares, so we just carry that down. 2x squared plus 3. So that means our answer for this particular question. So biggest thing is don't forget the difference of perfect squares. This part right here, ladies and gentlemen. This will give you the completely factored form. Number 30 is also a factoring problem. This is actually really just a base algebra 1 problem. You're just factoring a CB table, putting it in a box, and taking out your GCF. So A is 2 times our C is, sorry about that. That adds up to our B, which is negative 5. So you're finding the factors of negatives that add up to negative 5. Those factors are going to be negative 6 times 1. Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. So yes, this problem has y's in it. That just means there's y's at the last terms of each binomial. So x is 3y. Again, the a and the c stay the same. Now that you're here and you have 4 terms, you put it inside the box. So x squared plus 1xy minus y squared. And you want to take out the GCF going up. So when we look at 2x squared and y, they share an x. And then you ask yourself, x, get 2x squared, so you say 2x. 2x times y is negative 6xy. So we would say negative 3. And x times y, so you would say plus 1y. Double check negative 3y times 1y, give me negative 3y squared. It sure does. So your factors here are x minus 3y and 2x plus y. So up here at top, you would circle 2x plus y and x minus 3y. And last but not least, number 31 says find all of the zeros. So this is target 8D, all right? And when we look at this one, you first want to see, hey, do I have a GCF here? I do. You can take out an x from everything. So if we take out an x, we're left with x squared plus, okay? Now this x and this, remember, equals 0. So you want to set each factor equal to 0. So x equals 0 is going to be first x squared plus 16. In order to do that, we need to do our quadratic. Okay, so we end up getting x squared plus 0x plus 16 equals 0. So this is our A, our B, and our C. So I'm going to start off this with my discriminant, b squared minus 4ac. So that's going to be 0 squared minus 4 times 1 times 16. So that's going to give me negative 64. And we have to take the square root of negative 64. That's actually 8i. 64 is a perfect square. So now we take this. X equals negative plus or minus 8i divided by 2 times 1. And if you look at this again, it's 8i divided by 8 divided by 2 is going to give you first, which makes your answer B. And that concludes quarter 2 review. Please make sure you study for your quarter test. Remember, it is 20% of your grade. I hope this helps. Good luck!